Hey everyone, welcome to Module 2 of QR. This week we're going to be going over a couple of things. Obviously, the lesson for this week is about density. It's about material and population density. I'll get to that later in this video. But what else I want to talk about is I want to show you guys the solutions for Module 1. I'm going to talk a little bit about the comments you guys made. By the way, great comments. I got a lot of people saying that they enjoyed the video, and that's great. Um, but give me feedback also if you want me to add anything, if you want me to make things a little bit easier, if you want me to go faster or slow down in um, specific topics. Let me know so I could implement them in the next videos. One idea I got was um, put timestamps of different topics. So if you're watching this on YouTube, on the description, so on the bottom right here in the description, I'm going to put the timestamps for the different sections that I'm talking about. So I'm going to be talking about the quiz format, right? I'm going to be going over the syllabus that tells you when the quizzes and assignments are and how I expect to collect them. That's one. I'm going to be talking about the solutions for Mod 1, and then I'm going to be talking about population density, and then material density, and then I'm going to forward you guys to the worksheet. All right, so let's get started. So if you remember, if you click on syllabus, right, on Blackboard, we uploaded, Professor Fortier and I, we uploaded an updated syllabus. So if you click that, you'll come over here. I opened the PDF version, it's a lot easier for me to show. If you scroll all the way to the bottom, go. I know it's a lot of pages. Make sure to read this, and we're going to post up the video where we discuss this in detail soon. We go over every single aspect of this. Oh, by the way, I've been getting emails from students. Remember to read these netiquette rules, right? In the subject, when you're sending me an email, try to send it through your government email. If you haven't, if created one, contact IT. But if you're going to send it through a personal email, make sure you write your name on the subject, right? I'm getting emails from students, and I don't know who they are, and because of privacy issues, I'm um, hesitant about replying back, right? So make sure you write your names um, on the subject. And if you don't have access to a laptop, I think I had one question. Contact IT. We can send. I think we could send out. Government could send out a laptop to you. All right. Okay. So here's the syllabus. The schedule again, tentative. We're going to try to follow this as close as possible. But if any changes need to be made to the dates or anything, we'll definitely let you know. So I'm going to be focusing mostly on the QR part. I'm pretty sure. I'm assuming in today's Monday, in today's um, live session, Professor Fortier went over the critical issues component. But for the first two modules, there's really, other than the discussions, which every week it's due for the QR part, there's no assignments or quizzes. The first round of quizzes and assignments is starting next week, so module 3. So quizzes are going to be on Mondays, so the first one's going to be on the 28th, and assignments are on Sundays, right? So within that same week, you'll have two things according to this, but you'll have a week in between, right? So the quizzes are going to be in the beginning of the week on Mondays, and the assignment's going to be due at the end of the week, so on Sunday. So then you get to module 4, nothing. Module 5, again, beginning of the week quiz, end of the week assignment. Again, nothing due. Module 7, you have your integrated assignment one. We'll talk more about that at the end of this month. So near the end of September, we're going to be talking more about what we expect from that. But you'll have a quiz in the beginning of the module for module 7 for QR. And then you get to module 9, module 8, there's no quizzes or assignments. You get to module 9, you have a quiz 4, which is on the 9th of November, and then the end of the week on the 15th you have your assignment, going more and more. Again, then you have Thanksgiving recess, quiz 5 on module 11, the 30th of November, and assignment 4, which is the last assignment, in QR other than this integrated assignment is due on the 6th of December, and then all during the end, the 9th of December, you have integrated assignment 2. Again, we'll talk more about this in the upcoming um, lessons. Now, what are the structures? What are the structures of the quiz? Right. So imagine the quizzes are very similar to the worksheets in the sense that there will be you'll have a worksheet, right? So let's open up this one, right? Last week's worksheet. Let's open it up and I'll give you an example. Let's say this was the quiz, right? Again, the quiz format is you'll have 30 minutes to do them. It'll be open. The quiz will be open all day Monday, right? On Mondays, it'll be open all day. But once you start, there's a timer. You'll have 30 minutes to finish it, okay? So, and you only get one try. So make sure you're ready with your pen or pencil and paper, and I'll tell you why in a second. Make sure you're ready with all that before you start your quiz. And since you're taking it at home, it's open notes. You could use your notes and the worksheets that you have to help you in the quizzes, right? But again, you have 30 minutes, so try to not to spend too much time preparing after you started. Prepare before you start, right? And don't try to finish the quiz at 11:30 at night, right? Try to have it out the way as soon as possible. Okay, so imagine this was the quiz, right? So when module 3 opens up next week, I'm gonna put the worksheet, the quiz sheet, right? I'm gonna put it, and what I expect you guys to do. So imagine this was the quiz, right? I want you guys to take a piece of paper, loose leaf, right, and write down the questions and your name on your notebook, right? And your physical notebook. A student had asked me if you have a digital or a physical, try to have a physical notebook or a piece of paper, whatever you write with, right? So imagine this was quiz 1, and I'm going to write this on a notebook, and I'll show you guys why I'm doing this, right? You put your name in it, and while I'm talking, I'm actually writing on the notebook. So first question is 63 over 100. Remember how we converted that? That was 63 divided by 100, and we got 0.63, which is your decimal, and then that converts into multiplied by 100 to get your 63%, right? And I'm going to box my answers, and now I'm going to show you. So imagine this was quiz, and then they're going to be they're going to be one page. It's not going to be super long, right? The quizzes, so because obviously 30 minutes is not a lot of time, but I'm going to try to give you guys enough questions so you're busy for that 20 to 30 minutes, right? So now let me show you what I want you guys to do. I want you guys to, and I'm assuming everybody has a smartphone, right? And if you don't, make sure you contact me, because then we're going to have to talk about an alternative method. What I want you guys to do is open up, and I'm going to show my smartphone right now. Right, so I'm sharing my screen. Right, are we recording? Yep, we're still recording. That's my son in the back. He's 4 months now. But yeah, so what you want to do is go to the App Store. If you have an Android, there's I think the Play Store, same thing. Download this Tiny Scanner. Right, go to your search, Tiny Scanner. It might be called something similar to that, like Scanner app, right? Tiny Scanner, paper-free tool. Download this, right? I have to update it, but I'm just gonna leave it for now. But this can be very helpful in the quiz. Click on it. I think there's a video. Yeah, there's a video. Watch it. It's very helpful, right? But I'm gonna try to cover what we need for this class. So when you download it, this is what you get. Right, here's the app. The app's open. What's this? Oh, okay, that was in the back. Okay, now you click on this plus right here, and it asks you, do you want to access your camera or a document you have on your phone already. I just click camera. So here's my notebook, right? What I'm going to do is I'm just going to take a picture of my notebook. Takes a picture of it. If you zoom out a little bit, or if you take it from a little bit further away, you could actually like move this around, to crop it just to get whatever the portion you want. Again, I just wrote one question, but I expect all the answers here. And then you click the done button. Right over here on the name, just change it to your name. So I'm just gonna put Professor Khan. Right, don't put Professor Khan. Write your name. Quiz 1 done. Right, and hit save. Right, so I saved it as a quiz. Now if you wrote more than one page, you click on that, and then there's this button right here. You could add more pages to it. Hit plus. Again, it's my messy desk. And what am I? Yep, so if you have another page, right, you take another picture. Right, imagine you had written something here or here. You take another picture, and it's gonna let you drag it. So imagine I had more writing. Right, hit done. So save. So this was my page 1, this was my page 2. Again, your page 2, if you're gonna have a page 2, don't have it empty. Write your name in it as well. Next, you want to upload it. The way you do that is you press this, you email it to yourself, right? Email to yourself as a PDF, not a JPEG, right? If it's a PDF, then all the pictures are going to be in one page, right? That's going to make life a lot easier. Email to yourself, and then you will upload that PDF, right? Using your computer, you will upload that PDF onto the quiz file. Again, I'll show you more of that in how to upload on the next video. In module 3, when I post the quiz, I'll show you what I mean by uploading. Okay, it's very similar to the Blackboard discussions. There's that there's the paperclip that's uploading. You're going to upload your PDF like that. All right, so that's about the quizzes. Wow, for some reason my room just turned yellow, or the camera turned yellow. Let's see. Yeah, anyways, so that's how you're gonna work on your quiz on your notebooks, right? You're gonna take pictures using Tiny Scanner, or if you have any similar device. So and you're gonna upload that for the quiz. Again, 30 minutes. You get it's open the whole day, so find 30 minutes in the day to finish up the quiz. Be prepared before you start the quiz because there's a timer. All right. Next thing, what else was on my schedule? Again, great. A lot of good comments about being a good refresher last module, which is great. Some of you guys commented about the critical issues component on the QR. That's awesome, right? But the QR comments are specifically for QR, right? So this week's discussion, which is due on the 25th, I believe, is a Friday. Yep, the 25th by midnight. Make sure you get that and talk about this video, right? This video and the worksheet we're going to be talking about, and density and whatnot. Talk about that. Right now, before I start on density, let me go over. Let me just show you guys the solution for Module 1's worksheet. All right, so let me start with level 1. Right, so it's here. All right. If you need more information on that, make sure you come to my office hours or send me an email or write in the discussion post. Either you have multiple ways of contacting me. Right. Remember, Thursday, Fridays, 10 to 11 is office hours for me, and they're highly recommended. All right, guys. Even though they're optional, they're highly recommended. I guarantee you will learn a lot more if you attend them. So let me close this. Right. So here's again. You can pause the video anytime you want. I'm just gonna scroll down. What's happening? Why is it not scrolling down? Okay. Here's level 1. Here's level 2. Right, guys. And if you want any me to go over any specific questions, let me know as well. And then here's level 3. So these are the solutions for Module 1's worksheet. Now let's start talking about this week's module, what QR is going to be. So this week's going to be about density, right? Specifically material and population density for the purposes of this. So let's start with definitions. So density describes compactness and crowding. Basically, there's two types, material and population. Material density is the units of mass per unit of volume, such as grams per cubic centimeter. Density of water, which is 1 gram per cubic centimeter, is an example of material density. Hence, objects with density less than 1 gram per cubic centimeter floats in water, while higher density objects sink. And I'll talk about more about these definitions. With practice, it'll make more sense. Population density talks about how many people are compact in a certain unit area, right? Number of people per unit area. For example, if 7,500 people live in a city, that's 3 square miles, a small city, just an example. The population density is 22,500 people per square mile. Now, how do you get all that, right? How do you get to that? We're going to be learning through examples. Manhattan Island, right, has a population of 1.65 million people, right? So living in an area of only 23 miles, square miles. So what's the population density of Manhattan? So let's open up our notebooks and start this. Now the formula for population density is, where's my draw? Population density, right? We're going to write it as PD later on, equals population over area, right? Now the population here, right? Population of Manhattan is 1.65 million. Now remember, 1 million equals 1 with 6 zeros. So 1.6 million is 1650, and then the format is exactly the same. You have 1 and then you have 6 numbers afterwards, right? So that was what 1.6 means, right? Now, and we'll talk a little bit more about this in a second, right? Area, we said, was 23 square miles. So just plugging in this formula, PD is equal to population over area, 1650000 over 23. That gives us, let me take out my calculator, 000 divided by 23. That gives me 7173913. So about 71,739 people per square mile. People per square miles, right? Now, if you go round this, right? If you round it to, you can round it to this as well, right? If you round to a tenths place, that would be that. If you round it to the hundredths place, it'd be this. If you round to the thousandths place, it would be this right here, right? So let's talk about this for a little bit, because we discussed this in last week's lecture, what rounding to different places were, but in decimals, right? So if this is rounding tens place, that's this one. Rounding to hundreds place, that's this one. Rounding to thousands, that's this one, right? So remember, if you have a number, let's say this one right here, right? These are your decimals. This is your ones, tens, hundreds, thousands, 10,000s place, right? So that's how you would remember. And all these, the unit stays the same: people per square mile, people per square mile, people per square mile, right? So technically these are all the right answers, right? Depending what I ask, rounded, if it's a multiple choice, right? If I ask you round to the tens, hundreds, or thousands, you would give me the answers in that format, right? Again, tens, this becomes a 40 because there you look at your tens place, that's a 3, and the number next to it is a 9, so that since it's a 9 is greater than 5, it becomes a 4. When you're looking in the hundreds place, you look at the 100, right? You look at the number, get your hundreds place, the number next to it is a 3, so that means the 7 stays the same, everything else is zeros. If you look at the thousands, you look at your 1 and you look at the number next to it, right? It's a 7, so that means this bumps up to a 2, so that's how you get 72,000. So if we go back to the worksheet, right, again, same thing, a population of 1.65 million turns into 1,650,000. We get our area, we plug it in, and we get, and this one I routed to the tens place, so you get 71,740 people per square mile. Now, New Mexico has a population density of 16 people per square mile. Right here, I'm telling you the population density, and I'm asking for the area, right? So, and the area is about 120 people per 120,000 people per square mile. What's the population of New Mexico, right? Now to talk about this, I'm gonna talk a little bit about population density. Again, we're gonna work with some examples, and we're gonna break it down in a second. So let's open up a new sheet, right? So population density is, so let me take out population. The formula for population density is population, not that hard, right? Population over area, right? Now the area of the unit of area could be anything in terms of a distance squared, right? So unit for area, right? Unit could either be square miles, right? So miles, it could be square miles, right? Or it could be square kilometers, right? So you're going to see in different formats and different ways, right? So they could either be square miles or square kilometers, right? In most cases, we're going to look at square miles because in America we look at miles as opposed to kilometers, but in other metrics using countries, you're going to see square kilometers, right? So the way you could think of it is if you have some piece of land, right? Areas, remember, length times width, right? So if you have let's say 2 miles, right? This is your length, and your width is, let's say this is square, another 2 miles, right? Your area would be 2 miles times 2 miles, right? Because area is equal to length times width, right? That's what area is, right? So 2 miles times 2 miles is going to give you 4 square miles, right? Because you have two. We have 1 mile here, 1 mile here, so you're going to have mile squared, right? And instead of saying mile squared, what we say is square miles. So that's what the area would be. So for example, let's say the population in this region was 100 people, right? In this little town, square town, there's 100 people. I'm not going to draw out 100 people, but you'll get the point, right? There's 100 people that live in this little square town, right? So that means the population density, let's call it PD, right, is going to be 100 people divided by 4 square miles, right? So population density is going to be 100 divided by 4, 25 people per square mile, right? Per square mile. So that's going to be your answer. That's how you find the population density, right? So for every one square mile, there's about 25 people. So when there's an area of 4 square mile, there's a total of 100 people. All right. Now let's erase this, right? Right. Now let's use another example, right? Let's say you have a piece of land, right? That's not so symmetric, right? That's not, it's kind of like this shape, let's say, right? Like a little boot, right? And the shape is like this, and let's say this is 25 square miles, right? That's the area, right? The area is 25 square miles, and the population is 625 people. All right, so not that many, 625 people, right? So according to this formula, population density is going to equal to population 625 divided by 25, right? So this is the people, this is square mile, right? So 625 divided by 25, you could take out your calculator or you could use Desmos for this, right? Gives you 25 people per square mile. So for every square mile, that's your population density, right? For every square mile, there's 25 people, right? Now, let's delete this. Now, what if you knew the population density and you knew the population, but the area you wanted to find out, right? What if you wanted to find out the area? For example, let's say you knew the population density, right, equals 15 people per square mile, and you know the population is 1 million people, right? There's 1 million people, right? And there's 15 people per square mile. What's the area, right? So now to find that, we would look at this formula again. So PD, right, population density is equal to P over A. P we know, PD we know, PA is what we're trying to figure out, right? So let's try to work this around so we get A by itself, right? Now, whenever you need to remember, whenever a variable, in this case our variable is A because that's our unknown, whenever A is a denominator, right, to move it to the numerator, right, to move it up, what we do is multiply both sides by A. What would happen? This A would disappear and A would move over here. So area times population density equals to population. Now we want A by itself, so we have to get rid of population density. So we divide both sides by population density. That gets rid of the population density. We have A is equal to population over population density, right? So that's the formula, right? When you're looking for area, area is equal to population over population density, right? So let me erase this and use our new formula that we have, right? So A is equal to population, and population is 1 million people divided by population density, that's 15 people per square feet, per square mile. So A is going to be 1 million, that's how many, 6 zeros, right? Divided by 15, that gives you 66666.67 square miles, right? Or if you want to round it, right? If I tell you round to the nearest whole number, this would be 66,667 square miles, right? Don't forget this unit, square miles, right? Because you know this unit pops up right here. It's 15 people per square mile, and there's 15 people. So when you do this division, the people and people disappear, and all you're left with is the square mile for the area, right? So the area here is about 66,667 square miles, about there, right? Now, that's the case. So we know what the formula is when you want population density, right? Population density is equal to population divided by area. We know what the formula is for area. Area is population over density. What if now, this time, let's clear the board. What if we know the population density, we know the area, and we want to figure out what the population is, right? So the area is given, the population density is given, and they're asking for the population, right? So let's write down our formula again. PD equals to P over A, right? Again, this we know, population we want to find out, right? So let me erase this check marks, right? If we want to find out what P is, again, we want to move over this A. The way we do that is multiply both sides by A. That gets rid of the A. So we get area times population density equals population, right? So that's your formula, right? We can move it around. So population is going to equal area, right? Pop is going to equal to area times population density, right? So that last formula that has to do with population density, if you want to find what population is, that's just area times population density. If you want to find area, that's population divided by population density. If you want to find population density, that's population divided by area, right? So try to remember those three, right? Here's an example. Let's say you have an area, again, this is an example using the third type. Area equals 650 square miles. Population density, we know, right? Let's say that's given. Population density is about, let's say, 10 people per square mile, right? We want to know what the population is, right? What is the population, right? According to this formula, population is equal to area times population density, right? So that would mean P is equal to 650, which is your area, times 10, right? That's your population density, equals 6,500. Now, what crosses out? Here you have area, here you have population density. So square miles cancels out. All you're left with is just 6,500 people. Now, coming back from that video lesson, what do you think? How do we solve this, right? We know how to solve population. We know how to solve population density. We know how to solve area, right? We know all the different aspects of it, right? So how are we going to solve this? We're looking for population. So let's go back to our notebook, right? And they're asking us for, what are they asking us for? They're asking for us for population. What's happening? All right. So we know that population is equal to population density times area. Area is 120,000 square miles. Population density is 16.6 people per square mile, right? So you multiply these, and when you multiply, you get times 16.6, you get 1,992,000. Yeah, 1,900,000. What happens to the miles per square miles? Square miles cancels out, and we're talking about population, right? So we're going to say the population is 1,992,000 people, which, if you're rounding it to the millions place, right, is about 2 million. 2 million people, right? If you were rounding it to the millions place. So here's, we know population density is equal to population divided by area. We know population is equal to population density times area, as we discussed it a couple of minutes ago. And so population is about 2 million people. Now, we're going to be talking about material density, right? And we're going to start here with this example, and then we're going to talk a little bit more using different types of volume, right? So in this case, we have a cube, right? A cube of wood measures 3 centimeters on a side and weighs 20 grams. What is its density, and will it float on water? So let's scroll down. So cube is, again, it's like a square, right? But it's three-dimensional, right? So you can follow along with me while drawing this. Let me make this a little bit more cubic so it looks more square, right? That's a little bit more square. And it's 3 centimeters each side, right? And a cube, remember, just like a square, two-dimensional square is the same. If this was 3, this would also be 3, right? If length was 3, width would also be 3, right? On a cube, three-dimensionally, they're all the same. They're all the same size, right? So length is 3, width is 3, height is 3 centimeters, right? So these are all centimeters, right? So density of material, right? So material density, formula for that is equal to mass over volume, right? It's really important you understand this, mass over volume, right? Now the units for mass, right, I'm going to write over here, units for mass is most likely going to be grams or kilograms, right? Those are the usually two units we look at, grams or kilograms, right? Whereas the units for volume is either cubic centimeters or cubic meters, right? Or milliliters, and I'll talk more about that in a second, or liters, right? So these are the usual we look at when we talk about volumes of materials, right? Remember, cubic, right? Just like area is to the square, right, to the second power, volume is to the third power, right? The reason is because you have a cube, right? It's three-dimensional, it's a three-dimensional object, right? So if I was calculating the volume of this, right, it would be length times width times height, right? Three-dimensional. So this would be 3 cubed, excuse me, 3 squared times 3 cubic, 3 centimeters, excuse me, 3 centimeters times 3 centimeters times 3 centimeters, which gives us 3 times 3 times 3, which gives 27. We have 3 centimeters, 1, 2, and 3, so that gives us this right here. Now, this 3 has nothing to do with the fact that this is a um, uh, has a distance of 3, right? It has nothing to do with that. If this was a cube with a distance of 5, right? So all of these would be 5. All of this would be 5. Volume would be, again, length times width times height. It would be 5 centimeters times 5 centimeters times 5 centimeters. 5 times 5 times 5, 125. It would still be 3 centimeters, right? You have 3 units of centimeters, what makes it 3 cubic centimeters, right? That's where that 3 comes from, because it's 3-dimensional, right? Now, what if, how do we get the 3 cubic meters, right? So how do we get this one? So imagine we're looking at a big object, right? And imagine this was a really big object. So this was, instead of 5 centimeters, let's say it was 5 meters. So it's really big, right? So this was 5 meters on all sides, 5 meters on all sides. So again, same thing, 5 meters times 5 meters times 5 meters gives us 125 cubic meters, right? So that's how we get that 3. That's where we get that 3 from. All right, so let's go back to our question. So we have a cube, 3 centimeters on each side. So we know the volume, right? So the volume is equal to, oh, let me write it over here. We have, right, the volume goes on the bottom. Volume is equal to 27 cubic meters. And I think we also know the mass, right? Grams. So whenever you see grams or G's, that's your mass. Okay, so we have 20 grams. 20 G's, right? So now let's do the calculations. Let me move this over here, right? I forgot to move over the V. Let me just write this, right? So mass is equal to 20. Divide that up. 20 divided by 27, we get 0.74074074. So we're going to say 0.74 grams per cubic centimeter. So that's your density. Don't forget the units. The units are whatever's left over, right? G over cubic centimeters, G over cubic centimeters. Kind of similar to the population density, right? We have people over area. This is mass over volume. Very similar. So now let's compare it to our question. So our question asks a cube of wood. That's 3 centimeters on a side and weighs 20 grams. What's the density and will it float? Now, going by our steps, we had step 1, calculate the volume, right? Cube side is 3 centimeters, so cube's volume is 3 times 3 times 3, which is 27 cubic centimeters. Calculate the density. We know that this 27 cubic centimeters represents 20 grams, right? It's within the mass of 20 grams. So how do we calculate density, right? 1 centimeter would equal, this shouldn't say 1 centimeter, right? So density is equal to 20 divided by 27, which is equal to 0.74. That's what we got also. Now, the wood is 0.74. And remember from that first slide, right here, I said that water is 1, right? Water is 1, and wood is 0.74. So what's bigger, 1 or 0.74, right? 1 is bigger, and this is smaller. This has a lower density. Since wood has a lower density, this wood would float in water, right? So you could think of it as whatever has the lowest density floats, whatever has the higher density sinks. So in this case, the water is kind of like sinking, right? The water is in the bottom and the wood's on the top. So while we're on that subject of sinking and floating, let's talk a little bit more about different types of densities, different types of volumes, right? So in this case, what do we have? We had, let's say you had that glass, right? And we had water, right? And this piece of wood, right? Let me use red, I guess, right? This piece of wood that we had, it's going to float. The reason it's going to float because this has a density of 0.74 cubic centimeters, whereas the water is 1.00 or 1 um, gram per cubic centimeter, right? So the heavier one, the more dense one stays in the bottom, the lighter one stays on the top. Now, if you have nice objects like this, right? If you have any cubes, like I said before, right? Or a rectangular prism. So let's say in this case, we had a rectangular prism. So you have an object that's more like a rectangle, right? On this side, it's 4 centimeters. Height is 5 centimeters, even though it looks square, because I drew that. But the width, right, or the depth of it, let's say, is 10 centimeters, right? How would you find the density? Let's say the mass of this is 100 grams, right? 100 grams volume, you're going to have to calculate. I want you guys to find what's the, not population density, material density, so I'm just going to say density. What's the density of this block, right? What's the density of this block, and what do you think? Will it float or sink on water, right? So first step, volume, length times width times height. In this case, length times width times height, right? Length, let's say, is 4 centimeters, right? And it doesn't really matter which one you call length, width, or height, as long as you got 3 numbers, the 3 corresponding numbers, right? Width, let's say, is 10 centimeters, and height is 5 centimeters. So we multiply this out, 4 times 10, 40, 40 times 5, 200 cubic centimeters, right? So that's your volume. Mass is 100 grams, and we know that density equals m over v, which is equal to 100 grams over 200 cubic centimeters, which gives us, what does it give us? 100 divided by 200, which gives us 0.5 or 0.50 cubic um, cubic centimeters, right? 0.5 cubic centimeters, that's going to be your density of this block, right? Again, what do you think? Is it going to float or sink, right? So take a second to think about it. It's going to float because the density of this is lighter than water, and it's actually less than this, right? It's even less than this block right here, so it would float a lot. Now it would float even on top of this red block. Now what if we had an example where, let me move down, where it wasn't so nice, right? What if we had, and this will, trust me, you're going to get a question like this later on, right? What if we had a block that wasn't, it wasn't a block, right? What if we had an object that wasn't a block, right? When scientists did studies of volumes and densities, right, everything wasn't so nice and clear, right? What if you had a rock, right? Some rock from space, right? Some meteor, right? Right? Something like that, right? Obviously, this is not so nice. You can't really see what the distance of this, and like the depth. How do you even get the depth, right? It's hard to calculate that. So how, if you had a rock, right, you can find the mass of it easily, right? The mass of the rock, you just weigh it, right? You weigh it on a scale. Let's say this weighs 400, right? 400 grams, this rock, right? What's the volume? How do you find that, right? So that's tough. Now, maybe you guys did this kind of experiment in school, in high school or even middle school, right? The way you do this is you take a graduated cylinder, right? So you graduate a cylinder, which is, remember, it's a cylinder, right? It's a container with marks on it, with marks, and these marks represent, most of the time, is in milliliters, right? So these will be in milliliters. Um, so let's say it goes up from 0 to 100 milliliters, right? So this is 100 milliliters, this is 0 milliliters, right? There's no water, right? First thing you do is you fill this up to, so the way scientists did it at least, right? And hopefully you guys did this in your labs, but I'm gonna teach you how to do it. So first thing you do is you fill it up with water. So let's say you fill it up to this water, right? So here's some water, here's some water. Let's say that's about 50 milliliters of water, right? Then that's step one, right? That's step one. Step two is you put the rock in. So you put this rock in, right? You put this rock in. And if you ever like if you ever did something similar, right? If you have, let's say, a cup of water, right, and you put ice in or something, what happens to the water? The water rises, right? So now the water level rose. Let's say it's over here now, right? This is your new level, right? The water rose a little bit, and now this time it's, let's say, 75 milliliters, right? So before, without the rock, it was 50 milliliters. So step two, with the rock. Um, so this is with rock, and this is without rock, right? Or object. It doesn't have to be a rock. It could be whatever object you're trying to find the volume of, right? It rose up to a higher volume, right? Because remember, volume is your milliliters, right? So how do you find your volume? The volume of the rock is going to be volume of rock and water plus water, right? So minus volume of just water by itself, right? Now, don't get caught up with the words, right? Don't get caught up with the words too much, right? Think about what's happening. Volume of the water was just 50 milliliters, right? With the water and the rock, it became 75 milliliters, right? So if you take the volume of the water out from the volume of the rock and water, you're just going to get the rock by itself, right? Which here in this case is easy. 175 minus 50, you get 25 milliliters volume of the rock, right? I put V sub rock just for you to understand, right? So now we know what the volume of the rock is. We know what the mass of the rock is. So we could calculate what the density of the rock is. So the density is going to be, again, mass over volume, which is going to be 400 grams divided by 25 milliliters, which gives us, again, take out our calculator, divided by 25, 400 divided by 16 grams per milliliter. That is your density of the rock, right? So it's pretty heavy, pretty dense, excuse me, pretty dense. That's why it would most likely, it wouldn't even be here. It would fall to the floor, right? It would most likely be right here, because it's not gonna float. It's gonna sink completely, right? If water has a density of 1, this has a density of 16. This will go all the way to the bottom. Now, I'm gonna give you guys a hint on this, right? What if you had 3 substances, right? Now, let's say you had 3 chemicals, right? So chemical A, chemical B, and chemical C, right? And each one of them had different masses and different volumes, right? Mass, 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 and then I'm going to write equal. I'm going to tell you what the mass is in a second, right? And then they all had volumes, right? Volume, 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 right? And to get into a habit of organizing, right, you could use these subscripts. Oops, C, to help you. Volume A, volume B, volume C, right? So let's say this had a mass of 100 grams, this had a mass of 200 grams, this has a mass of 300 grams, this had a volume of 25 milliliters, right? This had of 20 milliliters, and this had and this had, what did I say? 60, something, let's say really high, 60, right? Let's say I had a question, right? Let's say you put all these chemicals in a beaker, right? You put all these chemicals in a beaker, and if you put these three chemicals into this beaker, what would be on the top, right? You wouldn't have these three mixing. Which chemical would be on the top, which chemical would be in the middle, which chemical would be in the end, right? Remember, it all has to do with densities, right? And I'm going to give them three different colors. Let's say the first one is black color, just to make this easy. Second one is red. Third one is blue, right? And we're going to work on each one of them individually. This one, density equals mass over volume, right? Very easy. 100 divided by 25 equals 4 grams per milliliter, right? Red chemical. Density equals mass over volume. 200 divided by 20 gives us 10 grams per milliliter. Last one, blue chemical. Density, mass over volume. 300 over 60 gives us 5 grams per milliliter, right? Now we're going to put them in order, right? So we have the blue one is 5 grams per liter, right? The black one is 4 grams per milliliter, and the red one is 10 grams per milliliter. Remember, the bigger the number, right, the higher the density is, the more it sinks. So this is going to be all the way in the bottom. Next, we're going to have the blue in the middle, and lastly, we're going to have the black, right? If you don't have different colors, just write them out, right? So in the beaker, we're going to have chemical A all the way in the top. It's the least dense, so it'll float. Next one is going to be chemical C, and lastly, it's going to be chemical B. Oops, let's use the red. Chemical B is going to sink because it's the most dense, right? And you could practice this, right? You can mix water, soap, and oil, right? You'll see different colors, right? They won't mix. Um, and different substances, they have different densities. So it's a pretty cool phenomena. I think back home in Bangladesh, there's this one place that has like a tea with 7 different colors, right? So they give you a big mug and it has like seven different colors of tea, and since they're different densities, I think it's called like rainbow tea or something. And since they're different densities, they don't interact with each other. But obviously, if you take a spoon and swirl it, then it's a different thing. But that's how different densities interact with each other, liquids especially. Now, lastly, I know we're spending a lot of time on density. I want to move around the equation so you guys understand how we could calculate different things. So density equals mass over volume, right? But what if you had, just like population density, what if you had volume density and you had mass? How would you find the volume? Very similar to finding the area. Multiply both sides by volume. Multiply both sides by volume. Volume cancels out. Volume times density, right, equals mass. You want density by itself, so you divide both sides by density. Divide both sides by density, you get volume equals mass. Volume equals mass divided by density, not destiny. Density, right? So this is your other formula, right? So volume is equal to mass times density. Now, what if you had density and you had volume, right? I'm going to erase this. What if you had density and you had volume and you're looking for mass? Again, very similar. Multiply both sides by volume, right? I'll write this one right here. You get volume times density equals mass, right? You want to find mass. Mass is equal to volume times density, right? Remember the formulas, right? These are, let me make the box around this, right? So these are the three main formulas you're going to try to remember. Let me put them all in one place. So volume density is equal to mass times volume. Mass is equal to density times volume. Volume is equal to mass over density, right? You could remember the units. You could go back earlier and see what the units are. Mass is always either gram or kilograms. Density is usually grams over cubic centimeters, or grams over milliliters, or whatever the volume is, right? Volume is either in cubic centimeters or cubic meters or milliliters or liters. All right, so going back to the module, right? So this week's module, module 2, it's live. When you click it, course modules, come on, load up. All right, come on. I don't know if Professor Fortier told you if you've attended his live session, but oh God, no. Yeah, so my internet has been acting up a lot this week. Let me try to get in again. All right, got it to work. All right, so module 2. And again, remember in the announcements, right, if you guys are taking breaks, make sure if you fast forward to this part, click on, right here. That's where the comments are going to be, right? Yep, so it's just refreshing and acting up. So QR lesson 2, the video lesson is going to be up, obviously, right? So if you're watching this, it's going to be here. The worksheet, right? Click on that, right? You get this worksheet, and very similar to the last one, right? You're going to work on this on your notebook. It's going to give you good practice for the quiz and assignments. Trust me. Let's zoom in a little. All right, and I'm not going to go over the questions here because they're very. This video lesson went on for long enough, and they're very similar to what we did in the examples that we did. Right, level 1, we're going to be looking at population density mostly. Right, I think that's population density is usually easier than material density. Right, so that's the first thing. Population density of China. Remember, population divided by area. Right, for each one of these, out of the 4 countries, which has the highest population density, highest and lowest, which has the highest land area, right? So look at the area for those. What's the population density of Wyoming? What's the population density of Pennsylvania? I give you the information that you need. Which state has the higher population density? Pennsylvania or Wyoming. Again, you'll get solutions at the beginning of next module, right? And you could use them to help you, right? Study those, and then you could use that to help you for the quiz. Next is level 2. Now you'll be calculating some material densities, right? Very similar. I tell you a block, right? A block is a cube, into some degree, right? I give you the volume. I give you the mass. What's the density, right? Here, volume, mass. What's the density? So on and so forth, right? Sometimes I give you the density and I give you the volume and ask you for the mass. Go back in the video, see how to calculate that, right? Sometimes I give you the volume. No, calculate the volume. So here now you're calculating the volume. You know the density, you know the mass, calculate the volume. So on and so forth, right? I give you very similar cube. Again, this is a teacher that uses a cork, displaces 23.5, right? Displace means that's how much it moved, right? So once they put the cork in, the water moved that much. So that's the, think about what that means, right? If the water moved that much, what's the volume of the cork? Right here, very similar to that example that we went over, right? Read each questions, right? Think about what they're asking, think about what's being given, and then move forward. Level 3, right? This might look like a lot, but it's not. It's exactly the same, right? I give you a small definition of density, right? You could copy this into your notebook, right? And you don't have to copy the words, right? Just say 1, 2, 3, 4. Right, that way you have an idea. Each one of them is a little bit different, right? I tell you to write the formula first. What are they asking for? Here they're asking for density, so write down the formula for density. Here they're asking for mass, formula for mass, formula for volume, formula for mass again, right? Read each questions carefully. I give you this table for a reason, right? Right? Think about why is this table given. Some of the questions refer to this table, right? So first you write down the formula, then you write the variables, right? Define the variables just like we did in the examples, right? What's the mass, what's the volume? What's the mass, what's the volume? What's given? Substitute them in, right? Substitute the variables into the formula. You get an example, right? You get density is equal to 250 grams over 100 centimeters cubed, right? Cubic centimeters, and then write your answer, right? This is really good practice. Trust me, this is really good practice, and continue work on. Try to use a pencil, right? When you're working on this, not pens. I don't want you guys crossing that a lot, but if you see mistakes, and you catch your mistake, that's awesome, right? And use the discussion post, right? So for example, you can say, hey, Professor Khan, I had a question about level 3, question 4, right? Or I had a question about the second chart, level 3, the second chart, right? Very similar, right? Here I'm asking you, I give you the mass, I give you the volume, you find the density, and you tell me what the substance is, right? The substances are correspond to this table right here, right? So you find what the density is, and then you tell me what you said, right? Use the density chart above to determine the identity of each substance, right? And this is exactly what scientists do when they find new material. They calculate the mass and volume, and they find what the density is, and then they compare it to what known substance that we have, right? So it's very similar. All right, so uh, make sure you look in the descriptions, complete the worksheet. In the comments, right, this week's comments, remember, talk about this video, talk about the worksheet. What did you like, what didn't you like, what was difficult, what not, right? And that's about it, right? So again, next week you're gonna have your first quiz on Monday. It's gonna be up the whole day, but once you start, 30 minutes, right? You get one chance, right? So make sure you're ready, right? Make sure you're ready. If anything happens, let me know. I'm gonna be online all day, hopefully. Fingers crossed. Internet's working. My provider's being really iffy with me right now, but I'll be on my phone all day. So if anything happens, let me know. If you get download that app. Don't wait until last minute, right? Once you see this video, along with the video, download that app. Try to get used to it, right? If you have questions about the app, let me know. Maybe somebody else might help you in the discussion board if they're having similar problems, but they fixed it, right? So the sooner, the better, right? Even though it's due this Friday, the discussion post, the sooner you post, the sooner you get your answers, and sooner you get practice at understanding this concept, right? And then use it during the quiz, right? The quiz is mostly going to be about what we did last week and a little bit about what you guys learned this week, right? About density. So make sure you're working on that. Assignment, I'm going to talk more about that next module. It's going to be due the Sunday, not this Sunday, the following Sunday. So what day is that? I think I already told you, the 4th of October. Yep. So October 4th, and I'll talk about what I expect from you guys. It can be very similar to the topics that we're going over, right? And I'll see you guys next. I'll see you if you're joining the Zoom session. I'll see you on Thursday or Friday. Remember, the link is exactly the same. And if you have trouble finding that, just let me know. Right? Send me emails. Remember, in the subject, put your name. If you're using a different email, salutations, and put your name in the emails as well if you're reaching out. All right, guys, take care.